So everything that we want to do detector related, I'm going to stick ZLP lock on, is over here in the EELS palette. So the 4 detector setups that we have are user, which we saw was really good for manually tuning the zero loss peak, HQ, HS, and HS plus. Really, this kind of become more relevant when we're doing spectrum imaging, but in summary, it's really down to what frame rate we want. So the differences between the 3 modes are the binning and the dynamic range. So HQ is unbinned, HS is binned by 2, HS plus is binned by 2, and with a smaller dynamic range so that we get a higher frame rate. So the frame rates that we have are 2700 FPS for HQ, 4500 for HS, and 8700 maximum for HS plus. So I'll just start a live view. And you see in the EELS palette, we have 2 parameters. So we have frame rate and live time. So if we're running a view time that's kind of shorter than the frame rate, then we're going to be at 100% live time. So that means maximum collection efficiency, 100%. If we go faster than the frame rate, so we're using the fast shutter to attenuate the beams, it's kind of like a partial frame exposure, then that live time comes right down. So you can see here that for HQ mode, the maximum frame rate is 2700 frames per second, but I'm running with a view time of 0.1 microseconds, which is way, way, way faster than 2700 frames per second. So this percentage here is saying that we're only exposing the sensor for less than 0.1% of the frame time. So it gives you an indication of collection efficiency or dose efficiency. So really, in summary, which of these we choose just depends on the frame rate you need. So just remember the 3 frame rates, and most of the time we use HQ. So I would say always use HQ unless you want to go faster than 2700 FPS. So maybe you're doing a high time resolution in situ experiment or something like that that requires a higher frame rate, and that's pretty much it. But more, we'll cover it, more in spectrum imaging as well. One final really important detector parameter that we need to consider relates to capture mode. I'm going to go back to the semiconductor example and the low dispersion to demonstrate. To get the best quality spectra, we always want to maximize our signal to make sure we have the best signal to noise ratio possible. This is why it's always a good idea to use auto exposure to get an idea of the maximum single frame exposure for the setup you're using. Remember that for this spectrum, our maximum single frame exposure is limited to 80 microseconds because the ZLP is in the field of view. Let's go back and look at the difference between view and capture in a bit more detail. And the 1 second capture will accumulate kind of frames of 80 microseconds. So it's going to sum individual spectra, which are kind of 80 microsecond spectra, up to 1 second. So let's try that. And for comparison, I'll stop the view. And one kind of nice thing that you can do if you want to move things from workspace to workspace, if we right click, there's this menu item at the bottom, which is duplicate on workspace. So I'm going to duplicate the view on the analytical workspace. So whenever we capture EELS data, the EELS data is going to get put in a new workspace, which will have the name analytical at the beginning. So this is our 1 second capture. So I just like to give them names, as we've all seen. 1 second capture, 80 microsecond frames. Perfect. And that's the view, I think. Yeah. Okay, so that's the view. That's the capture. So maybe it's easier if we have them on top of each other. So let's put one there and the other one there. And I'm going to use the splitter. Okay, so that's kind of handy. So we can look at the oxygen KH. Can we? Okay, so we can already see that the capture is helping us. So by grabbing more frames, we get more signal, and we can look out to higher energy. But we're still limited by the kind of the absolute noise floor. You can't just sum noise and kind of magically create a spectrum. So we have to have some measurable signal above our kind of baseline noise. One other thing that's kind of that we'd like to show you is that we have this other feature which really helps you when you do a capture, and that's the HQ dark reference. So what the HQ dark reference is, it's a multi-frame dark reference. So you have kind of two options. You either have one dark reference, but we have lots and lots of frames, so we need to dark correct all of those frames. But it doesn't really make sense to have one fixed dark reference and then kind of multiply that by the number of frames. That actually ends up increasing the noise quite a lot. A better approach is to have multiple dark frames and then kind of average. Because the noise is random, that has kind of a noise suppression or kind of a noise reduction effect. So the way we can see that, whenever you acquire the EELS data, it will always do, for a capture, it will always do an HQ dark, and we can choose to apply that or not. So let's go to image info. And then we go to the EELS section, and then HQ is currently enabled. And you can see the difference. So if we switch off this HQ dark reference, the spectrum becomes a lot less useful. So always, if you kind of want to have a higher quality spectrum, doing a capture is going to help you.